Assalamu alaikum. Can you hear my voice? Okay. So this is a revision class. As you all know, till now we have covered these topics: interfaces, polymorphism, inheritance, software lifecycle, recursion, sorting, and searching. Okay. Now, when you will prepare yourself for the term exam, you have to see the chapter goal first of all. Go to weekly instruction, week 1, week 2, up to week 6, and see the chapter goal. And then you have to prepare yourself accordingly. Okay. Now, first of all, we have interfaces. As you know, in interfaces, all methods defined in the interface type are first of all abstract. Can you tell me what is the meaning of abstract? No implementation, no code. Yes. Okay. It means that the methods which are there inside interfaces, they have no implementation. They are just declared. They are not defined. So you can say methods which are declared but not defined are known as abstract methods. And secondly, they are automatically public. What do you mean by public? What do you mean by public? We can call it from every class, implement from it, everyone can use. Every class. That means if inside a class we have other classes or other methods, okay, and if one method is being defined in one class and it is declared as public, we can use it in another classes, in other methods also. Okay, that's absolutely right. Now next is, they do not have instance variables. So you have to remember these 3 points, that if the methods are there inside an interface type, they are abstract, they are automatically public, and they do not have instance variables. What do you mean by instance variables? What do you mean by instance variables? There is no initial value, no. Final, private, no. This is very basic question, instance variable. We can use it only inside method. See, basically an instance variable is a variable which is defined in a class. That is, it is a member variable, and for which each object of the class is a separate copy or instance. Okay? So you can think of an instance variable that it is similar to and contrast with a class variable. You can think of it as a class variable. Now see this example. Here we have an interface called animal. And two methods are defined inside this. They are public in nature. And the name of these methods are eat and travel. So, as we have discussed, that they are automatically public and they are abstract. Okay? So you can see over here, we have used public keyword. Even if you will not use public keyword, there will be no error, because by default it will be considered as public. Okay? And if you want, you can use abstract keyword also before public. Abstract public void eat. Abstract public void travel. Now next is, we have another class that is mammal int, and it implements the animal class. So here, in case of interface, you have to use keyword implements instead of keyword extends. If we are working with inheritance, in inheritance we use extends keyword. But in case of interface, we use implements keyword. Now inside this class, mammal int, we have the mammal will inherit the behavior of animal interface. This is not inheritance, this is interface. So implements means whatever methods which are there inside interface animal, they will be defined inside this class. Okay? You can see over here we have these two methods. They are just declared, they are not defined. So when we use implements keyword, it means that whatever methods which are being declared inside animal interface, they will be implemented, they will be defined inside this class known as mammal int, which implements from the interface called animal. Is it clear? See, if we will use extends keyword, it means that the mammal will inherit the behavior of animal class. Okay? If we use extends keyword. But if we use implements keyword, it means that whatever methods which are being declared inside interface animal, they will be defined inside this class. Is it clear now? Now you see, so we have two methods. Now we have given their definition. These are the two methods. Their definition is here. And now inside main method, what we are doing, we are creating an object. We are creating an object of this class. So we have mammal int m. M is the name of object is equals to new mammal int. So you have to use new keyword if you want to create an object of a class. Why we create object? Why we create object? To call interface. No. In case of, even if we are not working with interfaces, still we create object of a class. Why we create object? To use the interface class. See, even if we are not working with interface, still we create object, as you have seen in polymorphism, in inheritance, and in number of programs. We have seen that we usually create object. So even if we are not working with interface, what's the reason? To get value, to apply the program. See, objects are created in order to call the methods. Okay? In order to call the methods. See here, we have two methods. Eat and travel. Now, how you can execute these methods? How you will execute these methods? Okay? In order to execute these methods, you have to call them. And in order to call them, you have to create an object. And by using this object, you can call these methods and then you can execute it. So we have m.eat. What will happen when m.eat will be executed? The control will be transferred to this function, eat. And then this statement will be printed, that is mammal eats. Now when we use m.travel, what will happen? This function will be called. So the control will be transferred to this function, public void travel. And then this statement will be displayed. So what will be the output of this program? When you will run this program, what will be the output? Mammal eats, mammal travels. Okay. So we have output, mammal eats and mammal travels. So you have seen that here what we have done, we have created an interface. Okay. And in that interface, we have two methods which were just declared, not defined. And then later on, we created another class. In that class, the definition of these methods are given. And in main function, these methods are called. Now, next concept is polymorphism. So as you know, polymorphism denotes the ability to treat objects with differences in behavior in a uniform way. So let's see an example. Here we have an employee class. And we have a method called mail check. Now we have a salary child class which extends the employee parent class. And inside this child class we have another method called salary and a method called mail check. You can see here we have a method called mail check, and by same name we have another method inside child class, and we have a set salary method. We use the mail check 2 times in a different way. Yes, see here we have this statement, mailing a check to, this is a string, and then the name and address. And what is here? What is the definition inside this method here? It's different. Okay? So it's within mail check of salary class, this is a string, and then it will print mailing check to, again a string, and then name and salary. Okay? So the name of method is same, but the definition of these two methods are different. In first case, it is defined inside parent class. In second case, it is defined inside child class. And then we have class called virtual demo, and we have a main method inside it. Okay. Now here what is done? Salary S is equals to new salary, and then this statement, and then employee E is equals to new salary, and then these set of arguments. So can you tell me what we are doing here in these two steps? Scanner, see, we have not used any scanner keyboard here. We are calling the method see what we have done here. We have get value by calling. See what we have done. We have created the object of salary class and employee class. We have created the object of salary class and employee class. Can you name the object? What is the name of object for salary class? Salary class object. And what is the name of employee class object? Okay. My question is, in these two statements, this one and this one, what we are doing? First question. So the answer of that question is we have created the object. In these two statements, we have created the object of salary class and employee class. Now next question is, what is the name of salary class object and what is the name of employee class object? Yes, S and E. Yes, absolutely right. S and E. So we have created two objects. Okay, you can see we have used new keyword also. Now next is system.out.println call mail check using salary reference. So this statement will be printed, and after that s.mail check. Okay, and then what we are doing, we are calling this method by using the object of salary class, and then this statement will be printed, call mail check using employee reference, and then we are calling the mail check method by using the object of employee class. We are calling a method to create an object which is S or a okay. Okay. Now, can you tell me what will be the output of this program? What will be the output? Remember that we have mail check method in both parent class as well as in child class. Same method we have, but the definition of these methods are different. So what will be the output? You see, the output is this one. So first of all, we have call mail check using salary reference. Why? Because we have this statement. So this statement is a string, because anything which is encoded within double quotes is treated as a string. So this will be printed as it is. So first of all, we have this statement as it is. It will be printed. Okay, and then the mail check method of the salary class is called. So inside salary class we have this method, and what is the first statement? Within mail check of salary class. So this statement will be printed. So we have this statement within mail check of salary class. Now we have mailing check to, and then plus get name, then with salary plus salary. So first of all, mailing check to will be printed. So we have this statement, this is string, mailing check to, and then the name. Now you see the name. What is the name? In salary class, this one. So this name is printed. And then we have the string called with salary. So we have with salary, and then the salary. So this is the salary. So this digit will be printed. Now next is call mail check using employee reference. So we have call mail check using employee reference. Then e.mail check. So now you can see, instead of calling the mail check method of parent class employee, the mail check method of salary class is called. the mail check method of salary class is called. That's why we have this statement within mail check of salary class, even though the method of parent class is called. You can see over here, this is an example of polymorphism. Okay. Now there are two things, method overloading and method overriding. Can you tell me this example is based on method overloading or method overriding? Overloading. Yes. This is an example of overloading. Now next is inheritance. So in inheritance, you know, we have a superclass, which is a more general class, and we have a subclass, which is more specialized class that inherits from the superclass. So you see this example. We have a class called animal, which is the parent class. And then we have a child class called mammal, and a child class called reptile, and another child class called dog. So these three child classes will inherit the properties of its parent class. So we have to use keyword extends. And then the name of parent class. So for mammal and reptile, the parent class is animal, and for dog, the parent class is mammal. So in this way, you can extend and you can inherit the methods and behavior of a parent class. Now there are some relationships. If you want to show an inheritance relationship, you have to use this symbol. You have to use a straight line and a triangle at the top. So this symbol is used to show inheritance relationship. If you want to show interface implementation, you have to use dotted line and an empty triangle at the top. And next we have aggregation. For this you have to use a straight line and a diamond shaped box at the top. And to show dependency, use dotted line and an empty arrowhead at the top. So these are the four symbols that you have to use to show different relationships like inheritance, interface implementation, aggregation, and dependency. Let's see an example. Here we have a class called car. These are the methods that are being declared as well as defined inside parent class car. The name of these methods are car info, set color, and set max speed. Now we have created a child class and it extends the parent class. A method called Maruti start demo is being defined inside this child class. Now we have another class called engine, and again we have two methods inside it, that is start and stop method. Here we have our class relations demo, inside which we have main method. Again we have created the object of this child class, and by using this object we call these methods set color, set max speed, and card info, and Maruti start demo. So when you will run this program, the output will be car color is equals to red, because we will call this method set color. So in set color, what we have, we set the color, and we have car color is equals to plus color. So the color is red. So the output will be car color is equals to red. And then max speed. So we have max speed is equals to the value of this variable. The value is assigned as 180. So this is the value 180. We have max speed is equals to 180. And then we have car info and Maruti start demo method. So inside Maruti start demo method, we are calling this start function, and the value of this start function is this one. So the output is engine started. If you have any question, you may ask. Okay, it's clear. Let's move to the next slide. So we have two relationships, that is our relationship and has our relationship. So between class car and this child class Maruti, the relationship is our relationship. And between these two classes, the relationship has our relationship. So there are two types of relationships, is our and has our relationship. Now next is software life cycle. So whenever we develop any software, during the development process, there are 5 basic steps. We have analysis phase, design phase, implementation phase, testing phase, and deployment phase. During analysis phase, we have to decide what the project is supposed to do. So here, the output of this phase is the requirement document, which describes what program will do once it is completed. Now here at this point, we are not concerned about code. Coding is not done at this phase. What we have to do, we have to just find out the requirement of software. And the output will be a user manual which will tell the user how the program will be operated. And it will also tell the performance criteria. Next phase is the design phase. Again, here we are not concerned about coding. We will just plan how to implement the system. So at this phase, generally, we prepare front end, or we can say we create interface. Or you can say front end is designed. So we have to discover the structure that underlies the problem to be solved, and we have to decide what classes and methods we will use. So the output of this phase is the description of classes and methods, and also the diagrams which show the relationship among the classes. So what type of relationships we have among classes? Is and has, exactly. So we have two types of relationships, is a relationship and has a relationship among classes, yes. Now next is implementation phase. Now here we will write and compile the code. And the code will implement all the classes and methods that we have decided in the design phase. So here we have decided the classes and methods, and here these classes and methods are implemented. So the output of this phase will be a complete program. A complete program. Now during testing phase, we will run tests to verify the program whether it works correctly or not. So we have different test cases, and based on those test cases, we will try to find out what is the result. So what we have different test cases. And we will find out that corresponding to a particular input, what is the output? What is the output? So finally, the output will be, the end result of this phase will be a report of tests and their results. So in the document, we will show what are the tests that we have done. That means the inputs. And what are the results? That means the output. And finally, deployment. In deployment, the user installs the program, and users use program for its intended purpose. That means whoever the end user is, the software is delivered to the end user. So in this phase, software is delivered to the end user. Now can you tell me what do you mean by end user? Yes. Who is the end user? The user of program, customer, okay. So the end user will be a person, or you can say customer, or you can say company, or any organization who will use that particular software. So it depends. Anyone user, yes, anyone. It may be a company, it may be an organization, a person, a customer, anyone. So the person who is using the software will be considered as an end user. Now, during software development process, we will follow different models. Can you name what are the two models that we follow during software development phase? What are the two models that we follow during software development phase? Although there are a number of models, but the two major ones are waterfall and this is spiral. Spiral. S C I R A L. Spiral. Okay. So we have waterfall model and spiral model. As a circle. So in waterfall model, we have a sequential process where we have different phases: analysis, design, implementation, testing, and deployment phase. So these phases are followed sequentially, one after another. Once this phase is completed, then only we can move on to next phase. So if you rigidly apply this waterfall model, it will not work, because the output of this model acts as an input for another phase. The output of this phase is an input for third phase. The output of this third step is the input for fourth phase. So you can see that when we are working on analysis phase, we cannot work on design, implementation, testing, and deployment phase. So it's a total wastage of time. So when rigidly applied waterfall model did not work. So what we have second option, that is spiral model. Now in spiral model, what we do, we create a prototype. Prototype is the exact replica of the original software that we will develop. So this model breaks the development process into multiple phases, and early phase focuses on the construction of prototype. Now you can see over here we have different iterations. This is iteration number 1, iteration number 2, and so on. So in the first iteration, what we have analysis phase, then we have design phase, implementation, testing, and deployment. Once this iteration is completed, the end result is a prototype. So now we can see what will our original software will be look alike. What will be the face of our software? Okay, it is the exact replica of the original one, but obviously it has limited functionalities, limited features, because we have not completed it. So the next iteration will begin, And again, we have all these phases: analysis, design, implementation, testing, and deployment. And the end product will be prototype 2. So now this prototype 2 will have additional features, additional methods, additional functionalities, and we can find out what we have done so far. And if any changes are required to be done, we can do it in the third iteration. So we have third iteration, and then this is our final product. So you can see over here, if we want to make any change, we can implement it. We still have time. So here we save manpower, we save time, we save money, and the final product has all features and functions which are required in that particular software. So obviously it also has some problem, like it can lead to many iterations and process can take too long to complete. But still, since we have prototypes, it is preferred than the waterfall model, because in waterfall we are working sequentially. But here, all phases are implemented and we get a prototype, and we can make out what further changes we can make in future. Any queries? Okay, so no questions. Then after that, we have recursion and searching and sorting techniques. So these topics we have discussed just now in the recent face-to-face lecture. If you want to ask anything related to recursion and searching and sorting, you may ask. So these topics we have discussed recently in face-to-face lecture last week and last to last week. If you have any question, you may ask. How it will be related to this topic? Sorry, the question is not clear. How it will be related to this topic? Please elaborate it. How the question will be? Yeah, questions will be it will be multiple choice questions or true and false. It may be asked that this sorting technique is better than other sorting technique. Which one is better? Whether which searching technique is better? Linear search is better, or binary search is better? Or it may be asked, the complexity can be asked. What is the complexity of the sorting and searching technique? Okay, and some recursive function can be given to you. You may be asked to find out what is the recursive function that is being defined inside a class or method. So questions can be like this, as a complete code or what? It depends. It depends. Means you have short answer type questions, you have multiple choice questions, true and false. So anything can be given. Some short answer type questions can be asked from you. What is recursion? What is what are the different sorting techniques, what are different searching techniques. Steps can be asked. If you are going to implement merge sort, suppose, what are the steps? Or if you have to implement selection sort, what are the steps? So it can be asked in the form of short answer type questions or in the form of multiple choice or true and false. No questions? Yes, thread. What do you want to ask about thread? What do you want to ask about thread? See, a thread of execution is the smallest sequence of program instructions that can be managed independently by an operating system. So it's a topic of operating system. Okay. If we are talking about thread, it is basically execution of the smallest sequence of program instructions that can be managed independently. So if we have a single processor, we have threads, thread 1, thread 2, thread 3. So these threads are executed independently. This topic is related to operating system. This topic is not related to programming. Mm-hmm. Anything related to programming? If you want to ask anything, you may ask. No questions. Okay. All the best for your midterm exam. Thank you all. Okay, what's the difference between recursion and iteration? See, in case of recursion, what we have, we will create a method, we will create a function, and that function will be called again and again recursively, okay? Now, what is iteration? Suppose I give for I is equals to 0, I is less than equals to n, I plus plus. What will happen? We have created a loop, and that loop will be executed until the value of I is less than equals to n. Yes, loop. So when we are talking about loop, it is basically an iteration. But if we are creating a function or method that is called recursively, that is called again and again, that is known as recursion. This is the difference. Okay, the difference is the recursion is calling a yes. Recursion is calling the method. Yes. Iteration implement the method. See, loop has different advantage. Recursion has different advantage. Like, I've given you an example. If you want to find out a number, what will you do? You have found out that in factorial, we have 5 into 4 into 3 into 2 into 1. Means every time the value of n is decremented by 1. Okay. Now, if you will not use recursion, what you have to do? You have to create 4 different functions. Recursion has its own advantages and loops have its own advantages. The function that is being performed by recursion cannot be done by using loops. Okay? Okay, all of you, you have your next lecture, I think. So all the best for your midterm exam. Assalamu alaikum.